Cubic Functions by Olivia, Carson, Becca, and Billy.
This is what a typical cubic graph looks like. Red is negative and blue is positive.
Domain is equal to all possible x values. And it goes from negative infinity to infinity.
Range is equal to all possible y values, negative infinity to infinity.
Here's how you show your intercepts, plot your points, and graph it.
So the equation we started off with was y equals x cubed plus x squared minus 4x minus 4. If you set that equation to 0, you get 0 equals x cubed plus x squared minus 4x minus 4. After you factor it out, you get 0 equals parentheses x plus 1, parentheses x plus 2, parentheses x minus 2. From there, you set each equation equal to 0. So then you get the first x equals negative 1, the second x equals negative 2, and the third x equals positive 2. So then you go and you plot those points right there. To find where the y-intercepts, you set x equal to 0, and there you get y equals negative 4. To find the other points on the graph, we set x equal to 1 and negative 3. And so there we plugged x into that, and then we got fx equals, the y is negative 6 and negative 10. So then you plotted them, you got 1, negative 6, and negative 3, 10. And then we proceeded to graph the line. Transformation. The equation for transformation is y equals a, open parentheses, x minus h, close parentheses, cubed plus k. K is whether or not it moves up or down. H is whether or not it goes left or right. A is if the line is tighter or looser. To transform, or to reflect, having a negative in front of the fx is reflected over the x-axis. Having a negative beside the x and the fx, that means it is reflected on the y-axis.
Real-life examples of cubic functions. Pumping water out of a tank, equation of state for real gases, finding interest rate, electrical resistance, and height of water in a spherical tank are all real-world applications.
Shapes found in the real world. We said that a shape found in the real world is like a giraffe, because the line on the back of a giraffe is just like the line graphed on the graph. And that is how you do cubic functions.